Hey everyone, so I just want to talk about one last thing in this first intro to energy unit, and that's going to be dealing with this idea called power. Now, just like with work and energy, we have a very scientific definition for power. Power is going to be represented by the capital P. The thing I want you to think about is what would you think a person would need to do in order for you to for you to see them as being powerful. Now, the go-to phrase is they have to be able to exert a lot of force. Now, if we want to kind of relate that back to this unit, that idea of exerting a lot of force is really just another way of saying, or a layman way of saying, exerting a lot, doing a lot of work. So, one way that you can consider a person powerful is that they can do a lot of work. You know, lifting up something very heavy versus something that's not as heavy. Um, Now, that's a very common definition, uh, but that really doesn't mean powerful. That means that you're really strong if you can do a lot of work, but it doesn't necessarily relate to power as far as we consider it. When we talk about power, we also consider how fast that work is being done. Consider the fact that if we considered two people bringing groceries upstairs, the person who took a long time, we wouldn't normally consider them to be more powerful than the person who was able to complete it much quicker. Likewise, if you have people pulling a car, the person who's able to pull the car faster would be seen as more powerful, even though they would both technically do the same amount of work by pulling the car. So, power, the scientific definition for power, is the rate at which work is done. It's not just about how much work you do, but how quickly you can do that work. So, if you want to be powerful, you not only have to do a lot of work, you have to do that very in a very short amount of time. This gives us the equation P equals delta E over delta T. You know, how much energy we can change divided by time. The unit for power is watts, or based off of this, since energy is in the units of joules and time is in the units of seconds, we could also say joules per second. Now, there are other equations we have for power. Um, that's the only one that's given on the reference table, but you can derive the others by remembering that we have this equation delta E equals W equals FD, and we can also use the average speed equation. What I can do is then combine them all together and say that this is another set of equations that we have. Since P equals delta E over delta E also equals W, and it's also equal to FD, and D over T is equal to V, so I could plug that in. So these are four, I guess, different equations that you can have based off of the scenario at hand. So if you're being told how much the potential energy changes, then this is the equation we would use. If we know how much work we do, then this is the equation we would use. If instead we're talking about how much force we apply and how fast we're doing it, like speed wise, then this last one is the one we'd want to use. So you pick the one that fits the scenario at hand. There's really not much else to talk about power. We're only going to do two questions, so this is going to be a very short video. So here's the first video. First question. Pause video. Work itself. I'm going to go in a second. All right. So based off of this, we have a distance, we have a force, we have a time. So the equation we want to use is FD over T. Plug our numbers in, and we get that the power is 90 watts. All right. And this is the last question. Pause the video. Work itself. We'll go over in a second. All right. So we have this. So we have an object that's lifting up a certain mass for speed. Now, since it's lifting the object up, that means that the force that is being exerted is going to be equal to the weight of the object, the gravitational force. So instead of P equals FV, I can actually replace F with mg to get mgv, plug the numbers in, and end up getting 80,000 watts. There are other ways that you go about doing this, but that's pretty much the simplest way. And that's it for power. Like I said, it's really just a one off question. Sometimes you might be given the question and you'll have to use it in order to find the energy in order to do something else. But for the most part, it's really plug and chug. Honestly, the concept of power actually is used a lot more in circuitry, which is no longer in the AP Physics 1 curriculum. So you don't really have to worry about that unless you're moving on to AP Physics 2 later on. All right, that's about it. If you have any other questions, feel free to let me know. Otherwise, good luck and have a great day.